whether or not it's right or wrong or not. So we're going to do the RAID 0 lab, but I'm also going to go ahead and talk about RAID 5, and then you'll do RAID 0 after you do RAID 5, because it's so much easier once you've done RAID 5 and you understand RAID 5 and you're not scared of it from that standpoint. So RAID 5. So RAID 5 usually has a card or something with it. It's to protect your system from downtime. So the whole point is a drive can die, one drive can die, and the whole system can still run. But the difference is that now it's got to do math. It's got to calculate your sectors because they don't exist. You're pulling it from memory. You're basically just trying to recreate it on the fly. So there's a situation where data then no longer exists. It's recreated from parity. And it kind of follows this whole A plus B equals C. If you have math and your drive is A and you have B, then you know what the answer to C is. But if you kill B, then you know what C is. So from C you can go back to B. So you can reverse the entire process. So that's what RAID 5's whole idea was. One can die, and then you can replace the one. When you put a new drive in, it will start to rebuild on that drive. And typically we're looking at like a 24-hour period of time that it takes for them to rebuild, and hope nothing else dies, nothing else happens, and that there is no other problem. So now this math and the process with math is done by what's called a discrete controller. So there's a difference now. Over the last couple of years, they've been making host-based controllers. Because we have really powerful processors, host-based controllers don't have their own processor. They use your processor. So basically they're a controller that steals your processor, and they cost less. So they save you money. That's why they exist. So you're talking about Rocket Raids and Adaptec stuff, and some Adaptecs have cards that have them, some that don't. AMI, there's a whole pile of them. There actually used to be quite a few developers and doing RAID stuff now, but we're really down to like 4. No matter what you're looking at as far as developers go for RAID arrays, there's only 4 main pieces of RAID code, and the rest of them are all copies of each other. So basically that's the difference between a host-based controller and a discrete controller. Is host is using your processor, and discrete is using a processor on the card. And you can tell by looking at a speed of a card, and you'll know if it's a discrete controller or not. And it's also divided by price. Most of the time it's $300 or more if it has a processor, and less than that probably doesn't have one. And this is why eBay is awesome, because you can buy a lot of good discrete controllers for like 50 bucks these days that people call obsolete, which I still think are awesome. So RAID 5. So that's basically the whole thing behind it. The problem is that there is something called parity, and parity is created by an exclusive OR routine. And so the exclusive OR routine is how this thing is calculating them, and you're doing it in software, you're doing it in hardware inside the system when a hard drive dies. So there's all these other pictures that show you blah blah blah. I made an animation. Let me show you my animation, and that will be more descriptive than any of these things. And I made this animation so as a managed IT guy. Some of you know, I manage servers, I manage equipment. I'd go into a company, and even though I'd tell them what they're going to do, sometimes I still have to have a slick presentation for them to understand. So if I went to a company, I told them I will support you, but I'm only going to support you if you buy this server, you buy a RAID array, you buy this. I had a description. I had a nice little animation I would show to them, say this is why you need this server. And so this was my animation that I used. It's not perfect, but it's come on. It's not perfect, but I also didn't want to complicate the issue. But in retrospect, I should have done it slightly different. I put all the parity on the bottom because I thought it'd be easier for them to understand. But parity actually is a calculation of the row. So it's here, and it actually goes diagonally. So you would have parity in a diagonal thing. But otherwise, it's pretty close to exact. All right, so this is my animation. So, some things are fairly accurate from a standpoint of you usually on a real card or controller, you actually get this alarm, and the alarm goes off and tells you that a drive died. And so that creates urgency. And once the alarm is turned off, urgency goes away. And then your boss is like, we don't have a drive in the budget. You must fill out paperwork, get a PO or whatever else. And then the reason we're seeing it in for recovery is another drive dies, right? But if you're explaining how RAID works, it's this. However many drives you have is how many slices you have. So if I have 4 drives, there's going to be 4. And if I add 5, there's going to be 5, and so on and so on. I have a minimum of 3 drives necessary. And the reason is because A plus B equals C. And so this isn't exactly right. This is to make it simple for a guy who had business class. It's exclusive OR. The routine is actually called an exclusive OR routine. And so each byte of a sector here is exclusive ORed with a byte of sectors here. And that produces a calculation called parity. Now here is the algorithm that exclusive OR depends on. If I can get to my desktop. Let's do this. Oh, that's a... Well, of course this is what happens when I move everything around. Come on, come on. I don't know why my system keeps pausing. Okay, so this is the exclusive OR routine. And so basically this is what you're looking at. If the sector is blank, is zeros, it is 0, then it is going to equal 0. So anywhere that the 2 items are equal, the answer is 0. So this is drive A. This is drive B. And then the data will be stored on a drive C, basically. So, but it moves the parity so that if any drive fails, that the parity will exist in a new location. So you don't lose all your parity. So the second one, if you look, wherever there's a 0 and a 1, the fallout is a 1. If you have a 1 and a 0, the fallout is a 1. But again, if you have a pair that matches 1 and 1, then it is a 0. Okay? So you only have to remember, if you have 1, the answer is 1. If you have 2 of anything else, it's always going to be 0. That's how parity is calculated. So if you actually look at the data on the drive, that's what you'll see is wherever I've got real data, then it calculates parity. It is going to be one of these answers. So no matter what happens, I can always tell you what the answer is, right? So if it's 0 and this drive is gone, and that's 0, what must the answer be? 1, right? Any of these, anything that you pick. If it's 1, that must be 0. If it's 0, it must be 1. And so on and so on. Does that make sense to everybody? If you have more drives, it calculates them in order. So what happens is it's A, exclusive OR, and then that answer, and then that is exclusive OR with the next one. So the more drives you have, the more they just chain across. But you do your answer, then you do your next calculation. Then you do your answer, then you do your next calculation. Okay? So it goes all the way across the drive like that. So you can open up a drive, and you can look at it, and you can stand here and do all the math you want. But I also asked somebody to build me a tool, and so in the runtime software, the same guys, Jody and those other guys, they actually added in an exclusive OR routine that does all the math for me in the tool already. All I have to do is put the drives in, and it'll tell me if I have all the parts. Now, this does not tell you the order. It only tells you you have them all. Right? The exclusive OR routine has nothing to do with order. It only tells you with, I possess them all. I have them all and they're all right. They might not be in the right order though. Everybody understand what I mean? Good? Because the answer is just an answer. It doesn't make any difference where the calculation exists. Okay? Alright, so. And there is calculators for all this if you want to do it. But I'm trying to avoid trying to teach people how to do the math. I'm going to try to find a way to tell you all the answers. So I get a mystery box, and the mystery box comes in. I have 3 hard drives in that mystery box. The first thing I need to know is disk order. And let's assume they didn't label it, they didn't tell me anything. The only thing they told me was it's RAID 5. Like somehow you've got to know. It's either RAID 5, it's RAID 0. You generally don't get 3 drives in a RAID 0. I'm going to tell you that right now. They'll do 2 or they'll do 4, but they seldom ever do 3. So, but in a RAID 5, you'll get 3, or you'll get 4, or you'll get 6, or you'll get 8. So there'll be a whole set of them from that standpoint. Now, you don't know your disk order, but you do know one thing. How do you know which one's the first one?
MBR.
MBR. So your MBR exists. You can always take 3 drives, figure out which one is 1, put that one in the first position. Now you've got to deal with the other 2, right? Then you also want to know, do you have your parity? Are all the drives together? Was there a 4th drive and they didn't give it to you? You can get the answer if you have 3 working drives out of 4. You only need X minus 1. So if I have 3 drives and one's dead and I can't get one to work, as long as I get the other 2 working, I can get all the data and I can recover it. I don't need the 3rd one to work, so I don't need to fix it. I don't do extra work. However, you got a problem, and here's the problem. In my diagram here, there's 4 drives, and that one died. Is the system still running? Yes, it'll keep on going. That system, an alarm will go off, and until you put a hard drive in, it'll rebuild. But this one's dead, but I'm still not going to see it. It's still not going to be in for recovery unless power outage, something weird happens and screws something up, right? When do I see it? When another drive dies. That's correct. So let's say these 2 drives are dead, and these 2 drives are good. Which one do I rebuild?
Which one's dead?
These 2 are dead. That's what you know. A box came in, you got 4 drives, 2 of them are dead. Which one do you rebuild?
RAID 5.
No, it's always RAID 5. It's RAID 5, but that's not.
Any one of them.
Why?
Because you can lose one with RAID 5.
Right? But you have a problem. Think about it. What do you need to know to rebuild it?
Parity?
No, I don't mean that. I mean, from a timing standpoint, what happened? The one that died last.
Oh, yes.
Right? So think about it. This died, and the system carried on. And when it carried on, you wrote some new files, you recalculated parity, so this changed, and this one changed, and this one changed, and it's recalculating everything, but this one's no longer in the system. It could be 6 months later. So all of this data changed. What happens if I put that back in the system?
Okay.
I've got data that's all misaligned. This data doesn't belong here. And I've seen Dell do this all the time. I'm calling for warranty support. No, you've got to test this. Well, the drive's offline. I can't do it. Force online. Have you heard this one? What happens if I tell there's a button in the Dell system on a RAID array that says force online? What happens if I force that online? It will shit itself. That's literally what happens. What happens is you are telling the array this drive is okay. And they needed to bring it online so they could test it. But that's the wrong way to do it. If you force online, you told the array, this drive's okay, I don't care what you say. And then what happens is the drive goes, oh, okay, if you say so, then I'm going to take this content and add it into all of the parity. And it corrupts all the data. It corrupts everything. All of this gets reweaved back into all of the other drives. That's a pretty damn near impossible situation to recover from, because there is no data anymore. It is all reweaved back together again, and it's a horrible, horrible situation. It's terrible. There's no easy way to reverse that at all. It's done. It's a done deal. You basically just overrode everything. See how bad that can be? So now, if this drive died last, then this drive has all the newest data on it. This drive does not, but you don't know which drive. This is the downside to rebuilding drives. You don't know which of those 2 that you need, because where's the log file? The log file that tells you which drives died, where is it? It's on that server. All of this data put together has a log file in it that says in the event log, oh, this died. And unless the company was big enough to have an SNMP server, like they'll have a server that collects logs offline. So that's one of the things that I suggest every IT guy do, is have just a small box or something that's running SNMP or something that can collect the logs from all the other boxes. Otherwise, you never know what happened. So I have to guess. I literally have to say, whew, I don't know which one I'm going to build, so I'll pick one. And I'll build it, and then you put it back in the array, and you see if the array works. And if you can't get a solution, you can tell by dates. This drive will still have MFT entries in it. Now remember, I showed you yesterday, I can go get MFT entries on a drive, right? I can get data back, I can tell it, give me just a quick scan. It'll collect all the MFT entries by looking at file records. And then they'll have dates and times inside those file records. So if this drive is running well enough, I can read that. I can actually say the dates on this one were 6 months earlier than the newest date on this one. So you can put 2 and 2 together and use your brain. I'm not going to spend a lot of time trying to explain that, but as a whole, you understand you can use a hex editor, you can search for file record, you can go in and look yourself and find what that content says the date and time is, and then go look and see if the other one has newer files. I do that all the time to find out if this one's older than those. If this one's newer and that one's older, so they should all be about the same dates. You should have some in there if any of those records were written. Everybody good? Okay? All right, so anyway, I must rebuild the last one. Where's your donor drive? Because RAID arrays, they want them done quick. They don't want to waste a lot of time. Where's your donor drive? Do you have time to order one online? I don't do that. I don't waste any of that time at all. I got 4 drives. I got donors. I tell the client, I say, listen, these drives are no longer going to be in use for you. You're already off on your world resetting up your server, and I'm working really hard to get this so that I can get this data back to you. Are you going to reuse these drives? They're not going to reuse these drives. Most of them are NAS boxes, and they went and bought another NAS box. They're not, unless they're in like a major server like a SAN or something, they're not reusing these drives. So what you do is, if these 2 are dead and you happen to need a rebuild, a donor to rebuild, you copy this drive twice, 2 times. Because what if your drive dies, then you're screwed, right? You make sure you have 2 copies of this. So you can do one as a clone and one as a in-case image. I don't care what you do as long as you got 2 copies of this drive. Then you tell the client, I'm going to disassemble this drive to make this other drive. Then you disassemble it and you rebuild this drive. Then you check and see. And you hope that you have the right one. If you do not have the right one and you've got to rebuild this one, I hope I can use the parts from these 2 drives to rebuild this one. If I cannot, I make 2 copies of this drive so I have images, and then I rebuild that one. You guys understand what I'm doing here, right? I'm going to use all of their equipment to rebuild their drives, and I'm going to get it done as quick as possible. It's going to be done same day maybe as it comes in. Because this is big money. How much money am I going to make?
$32.
I'm going to make $3,200 off of doing this RAID array. They're going to pay me $200 up front, and then I'm going to make $3,200 more. So I'm going to do it that day. I'm on this like trying not to say any other, it's like too bad. Anyway, so I'm on this right away. So I'm going to physically start rebuilding these drives. I'm going to let them know. I'm going to, I need these as donor drives, and I'm going to disassemble your drives. But they've already signed a warranty piece of paper too, so they already know I'm going to tear all this apart. So I just make 2 copies of that only to rebuild one. I don't copy anything I don't need until I'm done. But remember, I told you I would take all these over to DeepSpar. I don't know which 4 are working and which ones are dead. And I'm going to hit spacebar and I'm going to go through them, make sure they're not erased. I'm going to find the ones that are dead. Maybe I can copy them on a DeepSpar. Maybe they somewhat work. And maybe I don't even have to rebuild them. RAID arrays are very sensitive. If you get even a couple of bad sectors, the RAID array will kick the drive out. So it may not even be dead. It may be that the drive actually works and that 6 sectors went bad and it kicked it out.
Maybe just be smart attributes.
Yeah, smart attributes. Anything that the system reports to it, the drive will, the RAID array will just go. If smart says you've got 6 bad sectors, kicks it out. Any of that stuff will work. So I'm just saying there's a good chance with any of this stuff that I win. I win a lot. When you don't win is when the drives are erased. And Dell told them to erase them all. Okay, everybody good so far? Any questions? Good? All right, so I'm going to go through the rebuild process. Now so as I'm stepping through this now, I'm going to think of exclusive OR. This is the important part, okay? Controllers. Everybody thinks RAID arrays are doing whatever they want to in Yahoo land, and that RAID arrays can do anything they want. And that is not true. I'm going to tell you right now, 90, maybe 95% of all RAID arrays only use 2 configurations. Like 95%, all NAS boxes, all Linux arrays, all of those plugins, anything like that. The only ones that are different are the ones that have a big giant brand name on them. And when I say that, what I mean is Compaq, HP, IBM. Those guys are using another type of controller. It's still one of only 4. There's only 4 choices. But those guys use 2 alternate versions. But here's the cool thing about HP, Compaq, IBM, JFS, any of those big brand names. There's a configuration file on the disk. And software can parse the configuration file. So if you have any tool that reads automatic configuration files, Reclaim Me is one of them that will read the configuration file and tell you the order of the drives. There are $100 packages out there that you will read Compaq RAID arrays and it will tell you all of the settings for all of the drives. For $100, I'm making 32. So if I have a Compaq RAID array in, I can do it in minutes because it will tell me the configuration. But this is the mystery box. These are the NAS boxes that come in. These are the Netgears, the Buffaloes, the pile over at Best Buy right now that people are buying, the QNAPs, all those other ones, they're all coming in. I'm having to put all this together. Now here's the thing. Here's your choices. There's left asynchronous, and look at the drives. Drive 0, drive 1, drive 2. Watch the order. So slice 0, 1, 2, 3, then your parity. Then it starts over 4, 5, 6. Parity moves down the tree for the number of drives you have. So if there's 4 in this, there's 5 drives, there's going to be 5 parity slices. Then it's going to start over again and do it again. Understand? It's a looping pattern, over, over, over. This one's called left asynchronous. Watch the next one. This one is called left synchronous. So left synchronous does this. 0, 1, 2, 3, parity. 4, 5, 6, 7, parity. See the problem? Every one. I'm going to go back. I'm going to go back one. 0, 1, 2, 3, parity. 0, 1, 2, 3, parity. Remember the row across the top of the pictures that I said was always going to be the same if your order of your drives is in the correct order? But then you'll have a problem if there is an option for a change in the alignment, then your second row is wrong. Remember I had a picture that was supposed to be on the right, but it was on the left, right? And it should have been underneath the other side. That's 4. So that one should have been left synchronous, but it was doing left asynchronous. Do you guys understand? These are the 2 main ones. These actually have brand names, and I have them written down here, but one is AMI and one is Adaptec. So the brand names of the algorithms go with brand cards, but they're called left synchronous and left asynchronous. And they are AMI or Adaptec. So anybody who uses the same chipsets for any of those things all uses one of those variations. These are the primary 2 that you will always have. There are 4. here's the 4, here's the other 2. Write asynchronous, which starts parity on the other side. And then the same exact thing happens. Write synchronous. Now, listen to what I'm telling you right now. Unless you see a brand name that says Compaq, IBM, HP, something, you will not have, and I don't mean Dell. Dell does not use those. Dell uses Adaptex formats, so Adaptec and AMI. So those are the two they use. They always use less. On the big brand names, they use the rights. So any big brand name uses right choices. All the other ones are left. So I'm just telling you, 95% of your market is left synchronous or left asynchronous. That's it. So I can tell you right away, if you just eliminate the others, you won't need them. You'll use an automatic program to disassemble and put those back together. These are the ones that don't have a configuration file, or they don't have data, or you're doing them by hand. Understand? If you know anything about the controller and you go look the controller up, it will tell you what it uses. It actually will say, and sometimes they just use the initials, RS or RA. Organization of pattern, RS. Write synchronous. Organization of pattern, write asynchronous. So they'll say that on there. They'll tell you what they are in most of the controllers in their documentation if you're buying an expensive controller. Okay? So you can do some research. You don't need to know anything else. But I'm just telling you, if you're going to just play the game, all you have to do is use left asynchronous and left synchronous. Those two. Okay? So let's go down the list of things that is possible. So those two. Now I'm going to go back here and draw a picture again. Let's start over on RAID 5. You have two choices. Left synchronous and left asynchronous. You have 64K, and then you have your other choices, which will be 128, 256, and then usually down to 32, and then you still have 5, 12, and so on that you can do. Also, even though you can go all the way down to 2K and all the way up to 2 megs, most controllers do not do it. Most controllers, when you look them up and you find out, like IBM only does 4. IBM does not do more than 4. They on their slice sizes, if you happen to be using those, they only have 4 choices in their configuration. They don't have more, and not all of them do. Some will let you set it whatever you want, but some controllers limit them. Okay? But I'm going to tell you right now, the majority of what you're going to see in your life out of all these experiences is one of these 3. Almost always. So that's a good 95% of them right there. Okay? And then, what's the only thing that's left? What's the only thing you don't know? What? Order of the drives. So if you have a 3-drive array, 1, 2, 3. So that's what you need to know. So now, add these up. You know which one's the first drive. Which one's the first drive?
MBR.
The MBR. No matter what I tell you, no matter how many times I change it, edit it, do whatever, you load it up, it has MBR on it, you see it in hex, you're done, I know which one's number 1. No matter what. Then the rest of them, number 2, number 3, or 3 and 2, however you want to look at it. So I've only got, in this particular situation, I've only got 2 other variations, right? I can put 2 and 3 or 3 and 2. So I've got 1, 3, 2. Those are my only other choices. There's no other choices. So 1, 3, 2. So I've got 2 here. I've got 3 here. So each one of these could go with a slice size from 64K. So I've got totals of 4 that I could use. I always start at 64K. And then here I only have 2 choices. So now I break this down. The thing that I always do, that I always start with to begin with, is the order of the drives. So if I know 1, then I'm going to deal with 2 and 3. I'm going to start at 64K, always. And then you'll either be at left asynchronous or left synchronous. Those are your only other choices, whichever one comes up. So then my second choice will be 1, 3, 2, 64K, and then left asynchronous or synchronous, whichever one. Just stick with one, whichever one that you're doing. then after I know that this is the order of the drives, then the slice size, you have how many possible options? Let's just say we have 4, right? So we have 4 of these. How many options do you have here? So what do you think is easier to make changes to? 2 or 4? Let's stick with the 2. So I do these first. So my next one's going to be, if I was trying to figure that out, 1, 3, 2, and then 64K, stick with that. Then I try left synchronous or left, async, whatever it is. So I rotate those 2, whichever one that they are. And go on down the list. How many choices am I going to have when I'm done? So, because that's 2 of all of them, so I've got 3 choices. Then I've got 4 more on top of that for any one of those settings. Worst case scenario, 12, right? If I clicked and I knew nothing else, and I didn't use intelligence in any way, and I just go down the list and I wrote them all down, I've only got 12 possible choices, right? Unless you see Compaq, HP, IBM on something, then spend the $100 and use the software to tell you your answer, because there's going to be more drives than 3. There's going to be 8, and you're going to make a crap load of money in minutes, literally in minutes. I say use Reclaim Me. Reclaim Me Pro, I know it's $800, but it'll do it all for you. It'll do the whole thing for you, and it won't be minutes, but it'll do it for you, okay? Huh? It is. It's excellent. It's the best piece. It's a new piece of software. It's only been around 2.5, 3 years in the Pro version. There's a regular version, and there's a Pro version. Just get the Pro version. Don't bother. The regular version's fine for some low end, some free stuff and whatever, but the Pro version does all the stuff you guys will want to do. It does Drobos and QNAPs and all these other automatically. The only problem is time. If you feed it 4 terabyte drives, it's 4 days. So depending upon what it is, it won't give you the answer. I can still do it quicker than I can do that. But it's great at Christmas. I want to go home for the week and I just give it some drives and I walk away, right? So I still do it really quick in 45 minutes. But I'm just telling you, no matter what happens, just use logic and you're going to see I've only got about 12 options. I don't have more options. There's nothing else out there. That's it. There's 4 brands, 4 major brands. That's it. Nothing else is the same. Everything else is gone. Compaq uses something called delayed parity. So Compaq has a whole other piece. You don't really need to figure it out, but if you do, you only have 3 choices. So you only have 16 in a delay parity or 32 in a delay parity. And then if you have a big enough array, you might get 64. But you're not normally going to have anything that big. So let's do it. Let's go do, and then just real quick on. So I do not go and image all of the other drives. I deal with my repair drives. You have X minus 1. So if you have 3 drives, you must get 2 of those working. So you must always do that. If you don't get that working, if you have 14 drives and you don't get 13 drives working, you're done. There's nothing you can do. Or if 12 of those drives are 0, you're done. Well, don't waste time. Don't spend 6 months. I've had guys do that. Like they'll go rebuild drives. They'll get them all working. Then they'll go look at all the other array, and the other array is 0. Trust me when I tell you, look at all your drives first. Scroll through them in hex. Make sure they're not 0s. If they are 0s, that drive isn't going to help you at all. Nothing's going to be. Now, it can be a small chunk. You'll be surprised when you're looking at RAID arrays and you're looking at like a 4 terabyte drive that, 100 gigs is really small on a 4 terabyte drive, and the rest of the drive is going to be scrubbed, it's going to be 0s, so you're only looking at a small chunk. But just trust me, that's the whole point. Look at all the data, make sure that you're looking at it. And then I go through, and I don't even image anymore, I use them live on like a SAS controller or something. So, and then you're looking at these boundaries. So, and I did document FFD8, FFD9, and what I'm searching for. So I do kind of do this. I can go, this is just adding intelligence if you want to do it. You don't have to do this, it's just a step I can do. If I can't figure something out, I can go look at it. I go find an EXIF picture. So I go find a picture that has content in it. So this is EXIF information in the beginning of this picture. And then I cut out a chunk. I cut down, if it's 64K, I cut out a chunk, 32K. I save that to the desktop. Then I highlight it. I don't have the whole picture. I've only got 8K. I don't even have 64K or 32K. I have 8K. But this is the thumbnail that was embedded in there. And then you can tell the dimensions, and you can tell how big the picture is supposed to be. So when I go look up the picture, 10 megapixel, it's going to be about 2 megs-ish, something in that range. So then when I go look at the picture, like I can tell right away what my slice size is, because if your picture is 2 meg, just divide. Just divide by size. Then the other thing I'm looking to see, do I have all the picture that belongs to this picture? There's no other picture stuck in this picture, because then you've got a problem. You've either got stuff out of order, you've got something misaligned, or you don't have all your drives, or you have too many drives, you got something else. So you have to kind of use knowledge from that standpoint. But look, our row, I know there's not a lot to tell here, but across the top we got a stripe that's right. Then it rotates, right? Here's a box, a square, and it pushed the head, which would have been over here, around, and vice versa. So what I have here that's wrong is one of the orders. You should be able to recognize at this point that every time I have a line in a row in the next one, that's either LS or LA. That's either left synchronous or left. But the rest of it, I could have a slice size that's wrong, but I probably don't. But then I look at it and say, okay, let's rotate this. And then next thing is, what size do I have? And then we're going to do this in software. And then I can put the entire picture together. So let's do it for real. There is a piece of code that you can actually do if any of you are coders and you feel like it. I documented it. Alright, so I'm going to walk you through how to do this by hand, because it's not, it is in the book. It is, there's a couple of them that I did. Starting at page 645 is one version of the XF stuff, using Captain Nemo and RAID Reconstructor. It's an old program, been around for a long time. And then on 659, RStudios. So we're going to use RStudios to do the rebuild. Okay? So we're going to start with RStudios, and then I'm going to go backwards and show you runtime and how I can tell a lot of things in a minute or two. Okay? All right. So. Yep.
They send you a RAID.
Yep.
They let the RAID run for a month before they realize the one drive went bad.
Yep.
So now your other disk has updated information. This dead one's going to be a month behind.
Right, but you don't need the so are you describing 3 drives, 4 drives, how many drives?
4 drives.
Okay, 4 drives, and one is dead, and they didn't know about it, and the system was still running.
Yeah.
And what happened? Why are you seeing it?
Well, that's what I'm asking. They realized it was dead.
Yeah.
They don't know any better. They send it to you to recover it.
Okay. Well, then you don't have to do any rebuild at all. You just take those 3 drives, and you do a missing drive. So you can, in your RAID reconstruction process, there is the option for adding in a missing disk without rebuilding it. I'm going to show you where that is. But if you have 3 drives and you rebuilt all 3 drives, but like you said, one of them is behind. So I'm not going to add it back in. It's been dead for a while. It's only when it died and took the system down that you then try to rebuild that and bring it back in. But you only need X minus 1. So if you have 4, you only need 3 drives running in order to do the recovery. But you're right, you have to leave out the one that is the oldest. The data is now out of bounds. But if it took the server down when it went and lightning hit it and that drive is dead, well then all of it's in sync. But you don't need that drive. You only need 3 drives. Does that make sense? But you have to add in the position of the missing drive. If you have a missing drive, you have to add it into your program, into the configuration. All of them have a way to do that. Everybody good? Right? So, all right. So, on the laptop in front of you, in that images folder, there is a folder called RAID 5. So that same one that we've been doing, inside of this folder, there is one that's called Data Recovery Images. And if you go to the folder called RAID 5, you will now see the RAID 5 directory. It'll be a version 2. And in there, there's a pile of DD images. This is a 3 drive. It's a real hardware array. It's really one that I put on a hardware, assembled, did the whole thing, broke it, and then made backups of all the files. So we have a broken array. We do happen to have all of the drives. I didn't leave any out, but we can leave them out anytime we want to. We don't have to use all 3. We could just use 2. So we're going to start with 3, and you're welcome to do 2. You're welcome to do whatever you want to do. So you see the DD images? There's 1, there's 2, and there's 2, and there's 3. We don't need these ones called header. The header is just the information that went with the drive. It's not important. I don't need it. So we're only going to use the DD images. Everybody good so far? We're going to use multiple tools, but this is the drives that we're going to work on. Okay? All right, so I'm going to close this window. All right, so let's start with RStudios. In the bottom right-hand corner, go ahead and open RStudio. Now, RStudio is a little bit ugly again. Your drives are on the left-hand side, and all of your information about whatever drive or whatever you're clicking on is on the right. And it will periodically open tabs inside these windows. So you'll get tabs across the bottom, you'll get a tab across the top. So it does take a little bit to keep up with. You have to pay attention to where you're at. It is easy to lose your place in RStudios, okay? So, first thing we have to do is we have to add in our hard drives. Now, in real life, you can mix hard drives. Let's say I had 14 drives. I can plug 2 in over USB. I can plug 3 in over SAS. I can plug 6 in as images. I can pull 1 from the server. So I can get them from any source I want. All I have to do is get them into the interface. Everybody understand that so far? So that doesn't matter how I get them in. I've just got to plug them in. I will tell you, as I said before, if you're using USB, eventually it's going to crap out on you in the middle of the recovery. So buy a $50 Adaptec card ahead of time so that you have that. You also have to have cables, so you'll buy a card and cables, and there's SAS cables depending on how many drives you want to plug in. And so if you buy a 16-port array, buy a 16-port cable. Okay? So you can plug all those drives in at once. If you think you have 32 drives, buy 2 of those cards. Literally, it's going to be $100, and you're gonna love me for having one. I'm going to tell you, you can plug all your SATA drives into your SAS controller. I'll find one online for you guys if you want me to show you one. All right, so now go to Drive. We're going to plug in our drives. Go to Open Image. Now navigate to that same directory, RAID 5. Go into RAID 5, and then you're going to do the same thing in the little drop-down thing, say All Files. Now you can open all 3 at the same time if you hold down the Control key. So you hold the Control key, and you select the first DD image, second DD image, third DD image. That's all you have to do, and it will add them in there. And then you say Open. What's that? Yeah, Open Image, and then you hold down the Control key and you can select the 3 individual files. Now I could have played names, games, and stuff like that, but the problem is that no matter what I do, it's pretty easy to figure out which one's the first one.
You want us to open all 3 or just?
Yeah, open all 3, huh? Yeah, add all 3 in. So all 3 will be in the interface, and it'll look like this when we're done. There'll be a thing that says Image Files, and then you'll see 3 different drives, and you'll see a partition. Yes? Everybody seen that? Now again, we're assuming that our DeepSpar image we did right. We've fixed the drives. We've done all the stuff prior to this moment in time that we had to repair. Which one is the first one? Yep. Yep. So very easily, you could tell that the first one has a partition because that is the MBR that's showing you there. But let's assume we don't know that, and for some reason something didn't show us anything, or you doubt it. You can do this. Go to the first disk. Go to the disk, not to the partition. So it'll be hard to keep yourself off the partition because I know it looks nice and meaty there and says NTFS. But remember this, if you use the partition, you're 64 sectors away from the beginning of the drive. Remember, it starts at sector 63. So that means all your other drives have to be 64 sectors away as well. So every time that you're doing something, that's called an offset. So don't be in the wrong place, because they don't combine well when you're doing them the wrong direction. Everybody okay? Yes? No? Always start at the beginning. Make sure you're always on the same location. All right, so you can right-click on the image, and you will see View Edit. So I want you to open the View Edit and look at this in hex. So RStudios has a pretty decent hex editor in it. For 79 bucks, it's one hell of a buy. So if you look at this sector right away, it should be very familiar to you. We've looked at this on a deep spar. We've looked at this on other hard drives. You see at the bottom of the beginning of the sector, you have 55AA. That's what I look for first. I always look for, now I recognize every time I see a boot sector, I recognize the 3 and then the process from there. So I'm like, oh, this looks nice. I also look to make sure that in this part right here where it says invalid partition, blah, 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 that everything looks correct, like the text looks okay, so that it's not like a corrupted image or anything else like that, if text looks okay. And then right here, I look for 55AA, I make sure that looks good. And then the other thing I look at is these partitions, right? I told you right here, there's partition information right here. What type of partition does this say it is? Yep, 07, you know right away is NTFS. So, funny how that works out, right? So, I already know everything. Now, I also do this for every drive. I would grab the little scroll bar on this right-hand side and start scrolling down. Do I have data? 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 And then from here on, I might have a chunk of blank space, but I got a pretty good chunk of data here too. It's, 30% of the drive or so has data on it, which is about normal for a lot of RAID arrays that aren't full. If they aren't full, I mean, they've got 70 terabytes and they've only used 6, or something like that. Everybody good? You do this for every drive and make sure that they're not blank. That's what I would do every time. So I would close this, say I know which one's number 1, come to the second one, right click. This is to verify that you're doing your job. You'll notice this is not an MBR because this is the continuation of the data. And then from there on, as you scroll down, you'll see, do I have data, do I have data, do I have data? Then I do it for the third one. Now, I probably would have already done this on the deep spar before I ever repaired a hard drive. But that's the exact same thing that I'd be doing. Looking at the drives, looking at the drives. Good? So they all have about the same amount of data on them. That should be about right. They should all have very similar quantities and similar sectors that are filled up. Okay? So I looked at all 3. Everybody happy? Yes? Any questions? Okay. Now, I have the images loaded. Now this is where it gets a little bit confusing. Now the other thing is too, I want to point this out before we keep on going. You see this little log file down at the bottom? You see that error? What's it say?
Partition at 63.
Yep, so it says,
Disbound.
right? What's that mean? Why is there an error? So that you don't just ignore the error forever and ever and you know the difference between your errors.
It's formatted for the size of the whole RAID instead of a single drive.
Correct. It is.
It goes beyond the single drive.
So your MBR says, so if you have 3 hard drives in your array, these are 3 8 gig hard drives. How much space do I have available to my array?
24.
So there's 24 that goes into the array, but then 1/3 is always used for parity, right? So 1/3 of your drives is used for parity, and it is subtracted from usable space. So x minus 1 is always the space you have. So 24 minus 8. So you have 16. right? Your MBR says my partition is formatted for 16 gigs. So basically it knows it's 16 gigs. How big is a hard drive? 8. So when you open the MBR points beyond the end of the disk, past the end of the disk, because I only have 8 gigs, but it knows I have 16 in my partition, so therefore something's wrong. And that's why it says that when we loaded the images. Now, I'm fine because that's RAID, and I know that. It's okay. So, but that's why it says partition at 63 extends beyond the end of the disk bound. So if you saw that on another drive, that would be a problem, okay? But start thinking about what all those things are and what that error is. Now, here's the next thing, the part that's confusing. We need to create a fake controller. We're making our controller, and we're going to configure our controller the way we want to. And it's available in software to do whatever you want. So if you come up to the top, and there's a menu that says Create. Now, what type of RAID are we doing? So a volume set is volumes that go together. So that's like concatenated space. Mirror, we're not really doing a mirror, even though that would still fall under the RAID set. So the last one is called block RAID. So we're doing blocks, 64K blocks, block RAID. That's what this one's called. So create a virtual block RAID. Now you'll notice there's now a new item in your list. Now I hate that they numbered them this way. If you look, it says virtual block RAID 1. It confuses everybody because they're used to saying, well, I'm not making a RAID 1. And the next one you make is going to be called RAID 2. I'm not making RAID 2. So I usually correct it right away. So if you come over here to the right window, if you're highlighting RAID 1 and you go to the properties on that, you'll see the name, virtual block RAID. If you click in that box, you can make this say whatever you want. So I'll say RAID 5 array or something like that, so that I'm not screwing up making something. Or I'll name it after a customer, or I'll name it whatever, just something that I know what I want. Then you hit enter, and then it will refresh eventually. It'll come back over. When you come back over to that window, it'll refresh. So now I'm virtual block 5 RAID array. So at least I'm not confused now about what that says.
Did you just, I'm sorry, I didn't catch when you were changing the name,
Yeah.
did you just X out of properties?
You just hit enter when you're done making the change, and that's it.
I did, and it's still stuck.
Yeah. Now move your cursor to the left and click on your virtual block RAID again. Did it refresh? Yep. So as soon as you hit that window, it'll refresh. And then it goes back to this. Okay? Now this is the configuration of your RAID array. The white box in the middle is where you plug in your drives. The configuration stuff is on the right. So it's the type of RAID, your block size, and your order. And then on the left, it'll show you each drive in that box when we put it in. So here's the thing. Don't get confused about where you're working on. You are not working on image files. You are not working on all of these others. From this point on, anytime you ever make a RAID array, always make sure you're staying in the virtual volume area. Your cursor should never be anywhere else. People make this mistake all the time, and they'll end up scanning hard drives that are individual hard drives or individual images. Just trust me when I say, from this point forward, always double check when you move around that I'm in the virtual block volume, because you're going to leave it and then come back. And you need to make sure you're in the right place. Okay? So the next thing is we're going to plug in hard drives. Move your cursor to this white box and right click. When you do, you will see your list of hard drives that you have. Now, do not choose the one that says partition ever. But that one with partition tells you that you knew that that's the one that had an MBR. So select the one above it. It's always the one above it. So that's the one that we knew had an MBR. Select the one above the partition. Do not select the partition. Okay? Now it will remove it from your list. So if you right click again, you will see you can't accidentally choose that one again. So then just add the other two. And I also want to note, just to answer your question, Joe, is right here, missing disk. So if you were missing one, you can only be missing one. If you have one missing, you add it there, and it'll recalculate everything for you with a missing disk. So you can do it after we're done with our exam, and you can do the same thing. Okay? So you can go back and add and remove one and play with it. Okay? Good? No?
Yeah.
I mean, we'll do the lab, and then at the end you can take one out and put the missing disk in.
Well, I'm thinking if you can do that, then why repair the disk? Just put a missing disk in there.
Because you're almost always going to have a disk you need to repair. Because that's why you're seeing it for recovery. It's pretty rare that it was in the good state when you got it. There was something wrong with it. So almost always there's going to be something. Okay? All right. So add the other two in. Now you'll see you have a box. You have hard drive 1, hard drive 2, hard drive 3. Then you have your choices of your RAID type. Now, what type of RAID are we doing? RAID 5. Please change your configuration to RAID 5. We'll make this box bigger so everybody can see it. Alright, so now, RAID 5, its default is block size 64. And it's currently, if you just do a little drop down, don't change anything, but look at this. In this choices here, there's only 4. Now you can make your own. If you had a compact and you want to do a custom one, you can, and you know the layout, you can make it. You can make it whatever you want. The other really nice thing about our studios is, as best I can tell, I've never reached its limit. So I can keep adding hard drives in. If you go look at any other tool, X-Ways, you either only have 14 or 16, depending on which version that you're using. He expanded it one time. It used to be 14, now I think it's 16. You only have 16 drives. What happens when you have 32 drives? What happens when you have more than it does? You're stuck. And that's the same with a lot of tools. There's a lot of tools that have a limit on a number. Runtimes has a limit. It's I think it's 14. So this one, I've done 32 drives. I've done 60 drives in this tool. It uses a lot of memory. And I like to be on 64-bit operating system when I do it. But that's it. So these are your choices. And again, remember, we're only working with left. So it's either left synchronous or left asynchronous. But we're going to leave it where it's at right now. And then it added your parity. So you see, as we've done this, it added your parity. Now, here's a warning that I'm going to tell you right now. If you do this for a living, these drives are small drives. These, we're only dealing with 16 gigs of data. Right? If we were dealing with 4 terabyte drives or 32 drives, every time we touch anything in the box and we make a change, it can take time to shuffle it around and figure it out. So it's not super quick all the time when you're making a lot of changes. Like, I know I might need to make 6 changes when I'm setting it up. So I do not check that box at the beginning. At the end, whenever you're down to only making 1 change at a time, it saves you a lot of effort. So right now, I would say we can click this box so that we don't have to click more every time. Every time we'll have to click apply, and you'll forget to do it when you're in the middle of making changes. But don't do it when you're first setting up your array. Don't let that be the first thing you click. Wait till you're down to 1 change that you're going to make at a time. So click this box so that we don't have to keep doing it every time we make a change. And it will do it for us automatically. But I'm just telling you, it takes a really long time if you check that on 4 terabyte arrays. Okay, so now it's all set up and it's ready to go. Now, what I do next is I'm going to search for pictures. I'm not going to look at this drive. I'm not going to be confused by the layout. People start digging into stuff and they'll get confused really easy. The only thing I want to do is find 200, 1,000 pictures, and I want to find one that's 2 megs. And I want to see if it's right. That's what I want to do. That's all I want to do. I want to be fast. I'm literally going to do this as quick as possible, and I'm not going to be confused by anything else. So I'm going to move this box over so I can see. So I'm just going to keep all the defaults the way they were. the way they are in the system. Now you'll see I have a drive, I have a partition, and I have extra blah 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 whatever's there. It doesn't matter. I stay on the block. I stay on the top.